So now we are asked to verify one of the rules of inference. And we're going to do that using a truth table. So how many rows are we going to need? Well, there's only 2 propositions, so we need 4 rows. How about the columns? Well, we're going to have a column for P, a column for Q, a column for P implies Q. We'll have a column for P and P implies Q, and then we'll have a column for this whole antecedent and the consequent. So first, in this column, the conditional, the only way in which that can be false is if P is true and Q is false. We're saying P implies Q. So if P is false, then by default, this will be true. So anywhere that there is a false in P, these last 2 rows, this will be true. Okay, let's find a place in which P is true and Q is false. That only happens in row 2. So it's going to be false there. And then if both are true, of course, the conditional is true. Now, with this next column, what we are doing is we are actually comparing this column and P, this column. So remember, a conjunction is best to look at in terms of when it's false. If either of them are false, then it is false. So it will be false in row 2, 3, and 4. And true in row 1. So this last column, what we are actually comparing, this conditional, we are comparing that column with Q, that column. And remember, the antecedent must be true, and then Q false in order for it to be false. So the only place that the antecedent is true is right there. So that's the only option, that's the only possible row in which it can be false. Q must be false there, but it's not, it's true. So that happens to be true. And everywhere else, it's going to be true. And that right there is a tautology. When you see a column of T's, a column of truth, means that it's a tautology. And tautologies, they're very useful for constructing arguments, we will see later on.